Hello and welcome to another video in our series of video clips explaining ABES geometry control software. My name is Martin, and in this particular installment I would like to talk about another segment geometry segmentation topic. Specifically, I would like to talk about segment placement along curves, and especially on tight curves. I have prepared a small example for this purpose, which is shown here on the screen. It consists of one base segment here in the middle. This base segment is connected to the axis at this point here, at halfway point of the segment. On either side of this base segment, we have two matchcast segments, all assembled along a very tight curve. Now, the geometry and the measurements for this example are not realistic. They are chosen to illustrate the points I would like to make in this context. So as we can see, all the segments in this little example are placed in a second position, which means that if we look at the segment center lines, the blue lines here, the start and the end of the segment center lines are located smack on the alignment. The red line is the alignment, and with straight lines connecting that starting point and the end point. So at every segment, in the middle of the segment, as we move away from the start, a little gap forms between the segment center line and the actual road alignment. And that's clear because every segment is cast as a straight piece of concrete, and on a curved alignment, that's only natural to occur, this offset. Now let's zoom in on the base segment, or on the pier segment here, and let's have a closer look at the pier segment. Again, we have the segment center line starting on the alignment, then a gap opening and closing again, and at the end of the segment we reach the alignment again. The connection with the pier is established here in the middle. And if we look at that little red dot here, signifying the pier location in relation to the alignment, we can see that the segment center line has moved, or is located, a small way on the side. And if we look at the bearing positions, so I'm getting rid of the surface visualizations here, and we only see the joints. So here is the starting joint, here is the middle of the segment, and here is the end of the segment. If we look at the middle of the segment here, these two dots, they signify bearing locations, B1 and B2. And if we look at the bearing locations, we need to note that these bearing locations are symmetrical to the segment center line, but they are no longer symmetrical to the road alignment by this offset, or as a result of this offset. And that's something that is undesirable in many cases due to structural considerations, especially on a tight curve. So from this undesirable geometry, the demand arises that this segment needs to move over so this point matches the actual location of the pier on the road alignment, so that the two bearing locations become symmetrical to the road alignment. So let's have a quick look at the definition of this base segment here. This is the input dialog for this particular base segment, and the input element that I would like to point out here is this menu here, where it says segment center line, and the setting is the default setting, which is a secant. Now we can change this to tangent. And what this does is it tells the program, we accept that, it tells the program that if there is a connection point that's actually activated, this segment will be placed in tangent to the alignment at the connection point location. And if we go back to the drawing and if I press recalculate, this is what happens. This segment here, the base segment, has now moved outwards. So the segment center line becomes a tangent at the connection point, which is of course the pier top. And our two bearings are now perfectly symmetrical with regards to the segment center line as well as the road alignment. Now, as a consequence of this, the start and the end of the segment center line, is no longer on the alignment. That's clear because this is a curved alignment and we are in tangent here in the middle. So at the start and at the end, we are no longer on the actual alignment. This is a logical consequence, and that is not a problem. What the program now does is, it takes the adjacent next segment, which is still a matchcast segment defined as a secant, and it brings the segment center line back onto the alignment in this one transition segment. And once we are back on the alignment, the following segment is placed just as it was as a secant to our curved alignment. So here we have our tangent. The next segment will be a transition segment going from that offset at the end of the base segment back onto the alignment, and then it's just the default story again with a secant placement over here. If I switch on surface again to illustrate the whole road deck, this is what happens. We are here a little bit away from the alignment, but here we are on the alignment at the pier top, and our bearings are symmetrical with regards to the road alignment, which in a tight radius is something the structural engineers would like to see in a lot of cases. Now, there is one more aspect I would like to highlight before signing off. This example has been prepared with the default setting for the bulkhead direction, which is perpendicular to the segment center line. So starting from this side, here is a bulkhead, here is the segment center line, and the angle is a perfect 90 degrees. Same for this segment here. The segment center line and segment center line here and the joint, and again they are perfectly perpendicular. And as we come to the base segment here, it's perpendicular to the segment center line here as well as here. This leads to certain directions of the joints, and especially here around the pier segment, this is quite pronounced, or at least the difference between the joint direction and a perfectly radial direction to the center of the arc, is quite pronounced. And in some cases, it is desirable to cast the pier segment in a pie-shaped form that leads to joints that are in the radial direction of the curve. And although this is not quite the topic here, I'd like to point out that this can of course be achieved by redefining the base segment with the appropriate bulkhead angles. In this case, we've got 7.15 degrees. And if we do that at both ends and accept that, the joint directions, switch to radial, and this affects especially this joint here, and it does actually remediate this gap that we saw in the previous version of this example. Keep in mind this is a very exaggerated geometry due to the measurements that I've chosen, but even when this is less pronounced, the issue still exists, and it's of course up to the user to define this pier segment in the desired way, or in a way that can actually be cast in the casting yard.